All right, let's start. We have spent the past 2 units talking solely about triangles. All right, it's time to get away from the 3-sided figures and go to the 4-sided figures. All right, but you'll have to wait till Monday for that. All right, today I want to look at all the polygons, all the sided figures, and talk about how can I find an interior angle and an exterior angle of these polygons. All right, first thing, let's go down all the names of the ones we'll be responsible for. All right, some I'm sure you know, some you don't know. Maybe you know all of them. Who knows? All right, so the first one up there, 3 sides. I don't think we have to go over that. That's your basic triangle. Yep. Okay, moving on. 4-sided figure. That's the unit we're on, and that would be quadrilateral. A lot of people say rectangle, square. That is a type of quadrilateral. All right. Overall, it's called a quadrilateral. And you'll meet all the members of the family starting next week. 5-sided figure. Pentagon. And how about a 6-sided figure? Hexagon. And then usually this is where I start losing people. 7. I believe septagon is another way. I have heptagon. I think septagon is another version. 8, and it's not the stop sign. Octagon. My personal favorite, 9. Nonagon. Non-agon. 10. Decagon. 12. Dodecagon. 20. I don't know, because I'm not going to have you be responsible for it. We get anything above 12. You ready for this? This is how mathematically we're going to do it. I'm going to call it a 20gon. Okay, 20gon. Anything above 12, you just say the number of sides with gon. All right, so n, just be n-gon. All right. Okay. All right. Okay, so there are all the basic figures that we're going to be responsible for. Any questions on those names? All right, everyone, hopefully we know what a diagonal is. Yes? Okay, it connects 2 non-consecutive vertices. All right, so you can draw any sided figure you would like right now. I'll stick with my good old pentagon. And diagonal, again, connects 2 non-consecutive vertices. So there are 2 diagonals right there. All right, connects 2 non-consecutive vertices. Well, what if you connect 2 consecutive ones? It's called a side. All right, there are 2 types of polygons. One's called a convex, one's called a concave. Familiar with those at all, or? No? Okay, fine. Convex, all the diagonals are located inside the figure. No diagonal can be drawn outside, and you're probably like, that's everything. No, it's not. All right, so everything you're used to, sure. All right, everything you're used to was probably convex, where all these diagonals could be drawn inside. Well, what if I could draw a what's it look like if I could draw a diagonal on the outside, and what's it called? It's called concave. All right, a concave figure is when you can draw at least one of the diagonals on the outside, and here's what I'm talking about. That's not a polygon. Well, 1, 2, 3, 4, 5 sides. That's a pentagon, just not the way you like it to be drawn. And everyone see the diagonal I can draw on the outside, connecting 2 non-consecutive vertices right here. That's a diagonal I can draw on the outside, so I call that concave. The way I remember it, it's kind of caving in on itself, isn't it? All right, the polygon's starting to cave in. All right, so that's called a concave polygon. Here's what I want to do with you today. Hey, I have a decagon, a 10-sided figure. How many degrees are in that decagon? We need a way, because all you know right now is triangle 180 and probably quadrilateral 360. What about everything else? All right, there's got to be some pattern to it as well, which is the pattern you're going to find in your group right now. So here's your job in your group. You're going to take the following 5 figures: triangle, quadrilateral, pentagon, hexagon, and octagon. When you start working in your group, obviously you're going to fill in the number of sides. I don't have to fill in that for you. Now, the number of triangles formed. Let me show you what I mean by that. All right. We can fill it in for triangle real quick. There's only one triangle formed. And what's the sum of the interior angles? Okay, 180 degrees. That's not too bad. All right, let me go to my quadrilateral now. Here's what I mean by number of triangles that are formed. You are allowed to start at one vertice only, and coming from that one vertice, draw as many diagonals as you can. So I can only draw one diagonal. It's got to come from the same vertice, so I can't draw the other one in. All right, it's got to come from the same diagonal when you draw this, same vertice when you draw the diagonal in. Now, how many triangles did I form? 2. If you're ever wondering why it adds up to 360, well, how many degrees are in each triangle? 180 and 180, that adds up to 360. Okay, so that's what you're going to find right now for the pentagon, hexagon, and octagon. How many triangles can be formed drawing diagonals from one vertice? And then 180 in each triangle, how many total degrees are in each figure? And then hopefully you start seeing a pattern. So go ahead, I'll give you a couple minutes, work with your group. The diagonals can only be drawn from the same vertice, remember. And then see, once you fill in your chart, see if you can find a pattern. So if I give you now a 30-sided figure, you'd be able to find the sum of the interior angles using your pattern. All right, here we go. Let's report back and see if we find a pattern. Pentagon. How many triangles were formed in your pentagon? Let's start off. Let's hear from number 7 in Pentagon. How many were formed? 3 triangles formed. All 3 add up to 180. So how many total degrees in a pentagon? 540. Good. All right, let's keep going. How about the hexagon? How many triangles did you form? Hey, 23. How many did you form? 4. And all of them added up to 180. So how many total degrees? 720 degrees in every hexagon. And then finally, what about the octagon? How many triangles did you find? 15? 6. And how many total degrees in an octagon? What is it? 1080. I thought you said 180. 1080. Are we finding the pattern? So for instance, let me give you a 30gon right now. A polygon with a 30-sided figure. I don't want to draw it. We don't have time. 30 sides. Prediction, how many triangles? How do you get in that? Subtract 2 from the number of sides, and then I multiply that by 180. Not too sure what that is. 20. What do you got? 5,040 degrees in a 30gon. Okay, so you guys basically came up with the theorem for today. Right? The Polygon angle sum theorem. It's a mouthful, but we don't need to use it in a proof. We just need to find angles with it, which says the following. The sum of the interior angles of a polygon. Anybody describe it to me before I put it into symbols here? Number of sides, -2. Times, remember, I'm just finding the final answer here, the sum. So and the number of sides -2 times 180. And here's how we're going to write it. 180 times, in parentheses, n minus 2. And what do you think n represents here? Number of sides. All right, number of sides. You and your group, go right ahead. Numbers 1 and 2 right now. Numbers 1 and 2. One and two, 1 and 2. Okay, here we go. Let's get moving. Okay, number 6, going to need a little help from you. So I have this formula, 180 times n minus 2. What's my value of n for this one? Oh, value of n, 100 minus 2. So that's going to be 180 times 98. So how many degrees in a 100-sided figure?
17,640.
A lot of degrees, yes. Okay, a lot of degrees. All right, for the second one, first you had to identify what type of polygon it is. 23, how many sides did it have? Had 5 sides, so this is it is you're right, it's a polygon. Not going to argue with that, but more specifically, it is a pentagon. What's the sum of the interior angles we already figured out for a pentagon? 540 degrees. So what do we do to find x? Yep. So I took that 540, subtracted the other 4 angles. And what'd you get back there, Kate? 103 degrees. Nice job. All right. So we found some relationship between all the interior angles. There's got to be some relationship between the exterior too, probably. Right? All right, let's try to find that now. So I'm going to divide you up into 3 groups. All right, let's go. Let's go. I want to get going here. Let's go. It's been a while. Yeah, I know. Great. I'm not even responding to that.
Slide left. Slide to the right.
Anything else?
No, Orion. Stop.
Anything else? Okay, here we go. Everyone ready to vote? Curtains vote. 1, 2, 1, 2. 1, 2, 3, 4. Shatters. 1, 2, 3, 4, 5. I got pinwheels. I got cubes. Okay, I think we're done. Here we go. Okay, everybody ready? Cube or Promethean himself?
Big money, big money, big money.
Ooh, slide to the left. Oh, sorry to hear about that. All right, let's get back. All right. Okay, here's what I need you to do right now. On your specific figure, all right, I'm going to assign each group one of these figures here. I'd like you to find every exterior angle measure and let me know what it adds up to. Okay, let me know what it adds up to. So here you go. This group, these 3 groups right over on the left, you have figure 1. These 2 right in the middle, you got figure 2. And these 3 over here to the right, you have group 3. All right, find the exterior angles and add them up for me. All right, so find all your exterior angles and add them up. Report back to your group. Make sure you got the same sum of all your exterior angles. Make sure your sum matches, please.
Wait a minute.
All right, we ready to report back? Hopefully we can see a pattern from this. Group 1. What did all your exterior angles add up to be? 360 degrees. Group 2. What did yours all add up to? Whoa. Different sides, still the same amount of exterior angles All right, still this, excuse me, same number of sides, still the sum was the same for the exterior angles. And let's, group 3. So you're telling me no matter if you have 5, 4, or 3 sides, what's the sum of all the exterior angles? There's no rule. It's always 360. When you add up all the exterior angles of any polygon, it will always add up to, yes, 360 degrees. No fancy formula. It's always 360 for the sum. All right. Ready to get grinding here now. All right, so on the bottom, find the sum of the measures of the exterior angles of a polygon that has 36 sides. Guys, I don't care if I put 50 or 200 here. If you're telling me to find the sum of the exterior angles, it's always the same response, 360 degrees. We talked about, all right, now we've talked about all the interior angles added up, and we talked about all the exterior angles added up. Can we just find one now? Just one interior, that's it. I don't need to know what they all add up to. I just find one interior or one exterior. That's where we're headed to right now. Before we approach that, though, we got to talk about this huge concept, which is what the heck's a regular polygon? What's it sound like? Regular polygon. Normal, okay. Regular polygon. A square is a type of a regular quadrilateral. What's so great about a square then? Let's keep building here until we get the definition. There you go. Regular polygon. Number 1, all sides congruent. And there's another detail to it as well. All angles are the same measure, exterior and interior. All interior angles congruent and all exterior angles congruent. So for this first one here on number 4, I'm giving you a regular polygon, 20 sides. Wow. 20 sides. Find the degree measure of one exterior and one interior. All right, let's do the exterior first. What are all those exterior angles going to add up to? 360 degrees. And since we were told that it's regular, all of them are the same. So if I just want to find one now, what can I do with this 360? Divide it by 20. Yep. So each exterior angle for that 20-sided figure, 18 degrees. All right, good deal so far. But also I want to find one interior. It's very easy. It's always 360. Can you find what all the interior angles add up on a 20-sided figure? Have I given you something already today that will find that? What's the formula that'll find what all the interior angles add up to? Here you go. 3. Let's hear from you. What's the formula to find what they all add up to? No, I'm not there yet. I'm not exposing that yet. (180 times) what's my number of sides here? Minus 2. What is it? 3,240. Now that's the sum of all the interior. What am I asking for, everyone? One of them. But you know what about all 20 angles? They're all the same. So I could take that sum and divide by 20, and that'll give me an interior angle of 162. Now let's talk here. I didn't need to do all that work. All right, I did it on purpose, all right, because I didn't want anyone to get to the shortcut right away. But take a look, 18 and 162. One exterior, one interior. What should I know about the two? They're going to be supplementary, all right? So if you want to make a little note of that the interior angle plus an exterior equals 180. So if you know the exterior, just subtract from 180 and you got the interior. All right, I'm just going to try to mess with you now and see if I can trap you. Find the number of sides now of a regular polygon. One angle contains 120 degrees. One exterior angle, excuse me, is 120 degrees. One exterior angle is 120. It's a regular polygon. So what do you know about all the exterior angles then? They're all 120. What do they all add up to? 360. So I can take 360, divide by the one exterior angle, which I know they're all the same, of 120, and that tells me I have three sides, a triangle. Okay, now it's going to get a little tougher on you. What if I only give you an interior angle now? And number 6. All the sides are the same, all the angles are the same. One of those interior angles is 160. How many sides does it have now? Here's the problem. In number 5, I knew what they all added up to. I don't here. So I can't just take whatever that is and divide by 160. Is there a way around this? Is there a way around this? What do you got, Orion? There's an idea. Hey, if 160 is the interior, what's the exterior? 20. And we do know what they all add up to. All right, so find the exterior angle, which will be 20. And what do all those exteriors add up to? 360. So I can take 360 divided by that exterior, just like I did in number 5. That's all I'm doing, just like I did in number 5. And that'll tell me I'll have 18 sides. I'm going to go hands off and let you work on this last one with your group now. All right. This does not say it's regular, so don't try to get that into account. All it says is all the angles, interior angles, add up to 2,880. How many sides does it have? And don't guess and check, please. Let's try 12. Let's try 13. Let's try 14. Let's not guess and check. Let's get this algebraically right now. I'm giving you what all the interior angles add up to. How can you find the number of sides? Talk it over. All right, let's go back up here. 2,880, that's the sum of the interior angles. Haven't I given you a formula already today on where that number came from? What's that formula I had given you? 180 times n minus 2. And that should be equal to now 2,880. 80. Two different ways you can solve this. I'll show you both because you are in honors. You could do what to the 180? You could divide it on both sides right now to get rid of it. Some of you may have done what instead? Distribute it. Okay, either way is fine. You can distribute the 180 and go from there, or you can, yes, divide by both sides by 180 right now. So you get n minus 2 is equal to, we got 16. Add the 2 over. How many sides? 18 sides once again. All right. Questions, comments, any concerns? You guys see the homework down below and it's on the assignment sheet. Let's get it going.